Okay, good evening students. Hello.
Good evening, sir.
Yeah. So good evening all of you. So yesterday I have given you the introduction to propagation of electromagnetic waves. Right? Now you see students, electromagnetic waves containing information is generated by the transmission or the transmitting station. Okay. Now you see the science behind this. The electromagnetic waves, the way they propagate in the free space. The way they propagate in the free space, it itself involves so much of physics, and that's very interesting. Okay, I'm sure yesterday after brief introduction of what is ground wave propagation, what is sky wave propagation, and what is the space wave propagation, you must have been enthused, and I have also told you to read those 3 paragraphs given in the NCERT textbook with this background, and I expect that all of you have read it. Please be sincere. And if you have read that, and if you have got any specific doubt there in any of the sentence, please ask. I will be more than happy to explain it. Okay, wait. In the introductory paragraph 15.6, okay, I hope there is no doubt, or is there any doubt? No doubt. Okay, 15.6.1. Ground wave, right? So I'm sure you would have appreciated the sentence that the antenna length is it should be minimum lambda by 4. So that means now if you are having electromagnetic waves, carrier frequency which is low means it is in kilohertz. Low means kilohertz. So even kilohertz, you see 20 kilohertz carrier wave, what will be the antenna length? We just calculated the other day. What will be lambda by 4 for 20 kilohertz? So for 20 kilohertz, it is going to be 3 into 10 to the power of 8 divided by 20 kilohertz. Correct? So that approximate, and if you want, and this will be what? This will be lambda. And if I want it lambda by 4, then you divide this by 4. That is, the minimum antenna length should be so much. So this is approximately how much? Okay, so 3 by 4 is 0.75. 0.75 the other. Okay, that will come to 37.5. Correct? 37. See, 3 by 4 is 0.75. 0.75 divided by 2 is 37.5. Now, 10 to the power of 8 divided by 10 to the power of 4 becomes 10 to the power of 4. Clear? Hello? So, what is this? What is it I have written here? This is lambda by 4. Clear? Meters.
Yes, sir.
Am I right?
0.375.
0.375. Yes. 0.37. See, this will be 3 by 4 is 0.75. So this will be 0.375 into 10 to the power of 4. Okay, meters. So this comes to
that is 3750 meters.
3750 meters. Okay. So even at 20 kilohertz, and this is lambda by 4. I have calculated lambda by 4. So lambda by 4 means you will need an antenna which is 3.7 kilometers. Can you imagine 3.7 kilometers? It's a huge. So therefore, you see, even 20 kilohertz means you have to build an antenna which is so tall and practically extremely difficult to build. Okay, so you can appreciate it. So therefore, you will go for carrier frequencies which are much higher than this. Okay, so that the antenna size is reduced. However, since the higher frequencies are allocated for other services, at lower frequencies also, that is in several hundreds of kilohertz, you can still emit the electromagnetic waves. For example, you see now, what is the for amplitude modulation? It starts from 540 kilohertz. It starts from 540 kilohertz. So lambda by 4 at 540 will be what? 3 into 10 to the power of 8 divided by 540 into 1000 into 4. Correct? Hello? Hello? Are you with me?
Yes, sir.
So this becomes what? 3 ones are 3, 18.
Yes, sir.
Hello? 3 ones are 3, 18s are
Yes.
180. 180 into 4. So approximately what is it going to be? Right? So here 18 fours are is there, and here 4 zeros. 10 to the power of 4 divided by 18 into 4. 18 fours are 72.
Yes.
So approximately, if I just factor out 100 here, 100 divided with by 75, approximately 100. If I take this 75 close to 100, just I want to give you an andaz. If it is 540 kilohertz, okay, or if you want to calculate it,
1.5
5
into 10 power
into 10 to the power of
2.
2. That is 150 meters.
Hmm.
Correct?
Yes.
So therefore, you see, you can have an antenna of 150 meters. If you go to Dharwad radio station, here only, you can find that there is a huge antenna. Right? It's a huge antenna. So even 150 meters is huge. Anyways, you can go there and see. Now, that means now, okay, that means now, you see, this is the ground, and now you have the antenna. You have the antenna which is 150 meters. And what is the frequency? 540 kilohertz. Now, interestingly, you see, this antenna is fixed to the ground. Or at least on top of a building. On top of a building, still it is considered as ground. Now, interestingly, you see, the electromagnetic wave generated by this, is close to Earth. It is close to Earth. And as you know, electromagnetic waves has got electric field vectors and magnetic field vectors. This electric field vectors, okay, and Earth is a conductor, so this will induce current in the Earth. Yesterday I have explained this to you. And the current starts flowing, which is containing what? The information that has been superimposed on the electromagnetic waves. Now, you see the sentences here. You see the sentences here. It's very important. Okay, what is it they have told? The mode of propagation is called surface wave propagation. A wave induces current in the ground and passes through Earth. It is attenuated as a result of absorption by Earth. The attenuation of the surface wave increases rapidly with increase in frequency. That means now, if you have antenna situated on the ground, and if you are operating at carrier frequencies of higher frequencies, now it is 540, say around a megahertz or so, right? If you try to increase it, then ground wave propagation is not possible. Is that clear? So the ground wave propagation is possible at lower carrier frequencies. Did that convince you, students? Hello?
Yes, sir.
So the maximum range of coverages depends on the transmitted power. See here, this golden sentence, the maximum range of coverage for ground wave propagation depends on the transmitted power. How much power you are going to feed to the antenna, and the frequency less than few megahertz. I hope I made myself clear to you.
Yes, sir.
Yes. And as I told you, every sentence here can be converted into many questions for your examinations. Next, coming to this. Yes, please.
Sir, that you said no, sir, antenna height. That is measured with respect to ground level. Sir?
No. See, I am just taking this wire. This wire is what I am trying to tell.
So then how frequency will affect it?
How frequency will?
Affect it like
See, that's what. There is science of antenna. You have still got to study a lot of those things in the higher classes. Okay. In nutshell, you see what I have explained. You just confine to that. How frequency affects antenna, right? You have the science. Yes, you will get answers for those questions. Definitely, you will get answers for those questions. No doubt about it. Okay. Now I can explain that here, but it is going to consume some time, which is not useful for you for writing any of the examinations of second PUC. I'm sorry to say so. Okay, but definitely, as I have promised you, you finish writing your advanced examination. Next day, you can come to my home and ask these questions. I will satisfy you. Definitely, I will teach you. I know that. Okay, so after your advanced examination, you will still have 4 to 5 months time before you go to your engineering college. That time you come here, I will explain. You write down all the questions that you have asked, for which I have refused to answer. I'm sorry at this stage, but then please write those questions today, and after your exam, come to me. I will definitely give you the knowledge, because I know that. Okay, but right now I cannot. Huh? You just understand that it is possible. Thank you so much. Right. Now, coming to the next section, 15.3 table. See troposphere, stratosphere, mesosphere, thermosphere. I think all these spheres are there. You just read it and try to understand. What is important here is, well, questions can be coined on this also. Reflects low frequency, absorbs middle frequency, and some HFC, that frequency is most affected. Just have a just glance through it. Okay, it's important, right? Statistically important. Right, sky waves. So I am moving on to the next section, sky waves. Hello.
Yes, sir.
Now see. Yes, please. Yes, please.
So in the atmosphere layers, they are given day only, night
how means what?
So like day night, how it is?
Hey, need question. Day night. Last sentence I didn't hear. See, I am telling all of you. When you are speaking, you ensure that the other person is able to hear you very, very clearly. Understand? So you must keep your voice the amplitude should be same till you complete. So what is the question you asked? Please repeat.
They are given that exists during day, night, day only and outside. Like how will it affect?
How will it affect? Yeah, any student can answer this question. Come on, you have learned so much of science. See, you think like a science student, you will get the answer. So, day and night is going to affect, correct? Hello?
Yes, sir. Understood.
What did you understand?
Sir, like ionization is...
So you see, the sun's rays, it contains all the frequencies. Ultraviolet, okay, X-rays, all the frequencies are there in our SUN sun, correct?
Yes, sir.
And these are electromagnetic waves coming from sun. They have an influence on the atmosphere. Atmosphere is made up of particles, molecules of different, gases, etc. Okay, so everything happens. See, that's what, you're a good student. See, I feel proud that I'm a teacher, and I'm proud that you are a good student. All that my job is, to instigate you to ask question. And when you ask question, I have got to only guide you towards the answer. If I give the answer, I am not a good teacher. If my student with a small hint and direction, if he is able to answer, you have done your duty, I have done my duty. Great. So that's how you have to think. See, why I am telling this is because, if you see the examination questions, they will ask a question in such a manner. See, for example, how day and night will affect. That can be a question. I mean, we can coin a question around it. Then what will you do? Oh, iska theory मैंने नहीं पढ़ा, sir ने नहीं सिखाया, किस book में दिया है वो? That is not the way a science student should think, especially my students. You will say day and night. What happens in day? What happens in night? What is the difference? Oh, there is sun. There is no sun. Oh, what is sun? Sun is giving out these rays. And what can they do? They can do this. So that's how your thinking should go in that. If you develop this mindset, you can crack these examinations. Thank you. Sky waves. Okay, students, you see. Please. Ask.
Sir, now you said that day and night it will vary, but the sun is it will always be present, so the radiations are always coming from the sun.
This is not right. This is not right. This is not right. Don't you have night now? Sun is there, no? But still, why there is night here? Still, why there is night here? Hello? Still, why there is night here? Sun is here. Why there is night here? That is the answer, man. That is the answer. See, the sun's rays are not reaching the atmosphere on top of your head right now. Understand? The sun's rays are not reaching the top of your head right now. Okay? So, therefore, it has no effect. See, it is simple. See, you should avoid asking these questions. See, I gave you a hint. This is that boy understood. You should have also understood this. You should draw as earth, the sun, night. Sun rays are not reaching this part. So there is no chemical reaction or physical reaction. Whatever.
But we have one more here, ionosphere, sir.
Pardon?
So the part between the sun, we can use that.
Don't ask some stupid. See, this is very, very silly questions you are asking. Very silly questions. See, just because you want to ask questions, don't go on doing like that. Sun's rays should fall wherever the sun ray is falling. There is reaction. Otherwise, there is no reaction. That part only. Understand? See, now on other part, ionosphere is active, and this part ionosphere is not active. That's it. As simple as that. Okay, done. Now, sky waves. In the frequency range from few megahertz up to 30 to 40 megahertz. See, that word 30 to 40 megahertz is important. Long distance communication can be achieved by ionospheric reflection of radio waves back to Earth. This mode of propagation is called skywave propagation, used by shortwave broadcast services. The ionosphere is so called because of the presence of large number of ions or charged particles. It extends to a height of 65 to about 400 kilometers. See, these words are important. These numbers are important. Above the Earth's surface. Ionization occurs due to absorption of ultraviolet and other high energy radiation coming from sun by air molecules. The ionosphere is further subdivided into several areas. Details will be given 15.3. The degree of ionization varies with the height. The density of the atmosphere decreases with height. At greater heights, the solar radiation is intense, but there are few molecules to be ionized. Close to the Earth, even though the molecular concentration is very high, the radiation intensity is low, so the ionization is again low. However, at intermediate heights, there occurs peak ionization of density. The ionospheric layer acts as a reflector for certain range of frequencies, 3 to 30 megahertz. Electromagnetic waves of frequencies higher than 30 megahertz penetrate into ionosphere and escape. Yesterday I gave you the diagram for all this. I suppose all of you remember that. Hello? This phenomenon is shown in figure 45, the phenomenon of bending of EMAs so that they are diverted towards us is similar to total internal reflection in optics. Okay? See, this diagram is very, very clear. Okay, friends? Done. Okay. So now this is it. So when your carrier frequency is between 30 to how much? 300 megahertz. Sorry, 3 to 30 megahertz. 3 to 30 megahertz, ground wave is not possible, sky wave is possible. Above 30 megahertz, even ground wave and sky wave is not possible. We have to only go for space wave propagation. Simple. Right. So another mode of radio propagation is space wave. A space wave travels in a straight line from transmitting antenna to a receiving antenna. Space waves are used for line of sight communication. Here one thing you have to all understand. Okay, so now see, I am drawing the Earth surface like this. Now see, you have got a handset. Okay. Now this handset, it can be mobile or some walkie-talkie or something like that. So now this, if you are operating at frequencies greater than 30 megahertz, okay, or even for that matter, okay, see, it is for skywave, what is the frequencies? 3 to 30 megahertz, correct? For skywave. Hello, it is greater than 3 megahertz. Are you with me?
Yes, sir.
If it is greater than 3 megahertz, okay, that means now, you see, that means now the waves can travel like this. Got it? Hello? That means now if you have one more set here, this can directly receive the waves. This is called what? Line of sight communication. Okay, so if there is a receiver here, if there is a receiver here, this can also receive it. But only thing is, if it is sky wave, this can travel only up to certain distance. It hits the ionosphere, then it comes. But if the frequency is greater than 30 megahertz, then then again this is possible. Line of sight is possible. If you have something here, it can be possible. But a wave which is traveling like this, it will not return back to ground, it will keep going. That's the only difference. So line of sight is possible at almost all frequencies. Only ground wave.
Line of sight.
Line of sight means? Yes, please.
The line of sight means from that transmitter directly to the device.
Point to point. Point to point. Line of sight. You can see, no. If your friend is standing there, you can see, no. That's called line of sight. See, for example, even this way you see. Our Earth is like this. Okay. Now, supposing I have an antenna here like this. I have an antenna here like this. Okay. Now, see here very carefully. Now there are many waves traveling in different directions. So you can see now one wave traveling like this. It is just skimming the surface of Earth. Got it? Hello?
Yes, sir.
This is one antenna, it is skimming. Now here if you have another antenna. Here if you have another antenna. So from this antenna to this antenna, the line of sight is possible. Got it?
Yes, sir.
But yes, sir, so 15 point, network issue. 15.5 diagram. Can you see the diagram 15.5?
Yes, sir.
See there. They have shown two antennas. HT transmitting antenna, HR receiving antenna, heights they are told, and the distance between them and DM it is told, right? And then you have what a formula here. DM is equal to, see, 15.1 equation. Okay, 15.1 root 2 RHT plus root 2 RHR, where HR is the height of the receiving antenna. What is this DM? DM is the maximum line of sight distance between the two antennas. It's very clearly written there. Okay? So, space wave travels, frequency is above 40 MHz, communication is essentially due to line of sight paths. At these frequencies, antennas are relatively smaller and can be placed at heights of many wavelengths above the ground. Because of the line of sight nature of propagation, direct waves are blocked at some point by the curvature of Earth. If the signal is to be received beyond horizon, receiving antenna must be high enough to intercept the line of sight. Okay, so line of sight is possible. But that means now you see, I can put an antenna here, I can put an antenna here. But supposing I want to receive it here, receive at this point, then what should I do? I should have an antenna which is big like this. I can still receive. Hello, are you with me?
Yes, sir.
It is possible. But again, you know, this height of the antenna and all. Height of the antenna means, now you see here. Now understand this. The antenna, antenna height can only be so much. But this antenna should be placed on something. Correct? See, antenna height here means antenna can be, see, now the antenna of your phone here. There is an antenna here, it is very, very small. So, the antenna here, but what is meant with this line of sight? This height of the antenna means height at which the antenna is kept. Height at which the antenna is kept. That is the height of antenna. Okay, right. Now, supposing you want to receive the signal here. Now, you can't have line of sight. Then you will go for this, as I told you yesterday. Hello? Hello? And now if there is ionosphere, then it can get reflected. And you can still reach this point. Got it? But if it is here, then even the ionosphere cannot help you. Skywave is not possible. Then you should have frequencies above 40 MHz, which should go and reach a satellite, and from this satellite, it will go to another satellite, and from that satellite, it can come to this. Okay, so that is how we are all able to receive long distance calls and all those things. And Earth's radius is 6,400 kilometers, etc. etc. Okay, I think this is clear. Skywaves. Now television broadcast. Microwave links and satellite communication are examples of communication which use space wave mode of propagation. Right. So everything is very nicely given here. Ground wave, sky wave, space wave, beautiful. Right. There's a small what is it, numerical illustration is given, I'm sure you will be able to understand that. Let me not discuss it. So I suppose this propagation of waves is clear to all of you. Hello?
Yes, sir.
Right. So modulation and its necessity we have covered yesterday, right? And now, most important, amplitude modulation, right? 15.8. Hello? Hello students?
Yes, sir.
I had requested you from past 3 days to learn and come. If you have learned and come, within no time you will understand. Otherwise, it will be slightly difficult to understand this. Right. I hope you are having the textbook there in front of you. Now, there are different modulations. Amplitude modulation, frequency modulation and phase modulation. I have explained all of them to you in nutshell. Now, specifically, to some extent, we will understand how amplitude modulation takes place. Right? Hello?
Yes, sir.
Great. So, here you see. Let me start explaining to you. So here, in amplitude modulation, the amplitude of the carrier is varied in accordance with the information signal. That is, at every instant, the amplitude of the carrier is controlled by the modulating signal. Correct? That is the golden sentence that we have seen. Here we explain amplitude modulation process using sinusoidal as modulating signal. Correct? That means now amplitude modulation can be done with any modulating waveform. It need not be sinusoidal. But for the sake of brevity, for beginners, we are using sinusoidal modulation. I hope I made myself clear. Right.
Yes.
Now, let C of t is equal to AC sin omega ct represent the carrier wave. M of t, AM sin omega mt represent the message or modulating signal. Omega m is equal to 2 pi fm is the angular frequency of the message signal. The modulated signal C suffix m of t can be written as Cm of t is equal to AC. I hope you are able to see that. Right?
Yes, sir.
Now what you see there is the amplitude of the carrier. So the carrier signal initially was this AC sin of omega c t. Okay. Now this amplitude. Now don't. Yesterday I think this clarity I gave you. Here AC means the maximum displacement. That is what we have studied. Okay. Now here in this context, what you have to understand is, you see here, this, what you have to understand is, what is AC sin omega ct? What is AC sin omega ct? It is nothing but the displacement of the part of the physical quantity from its mean position. What I mean is, if the sinusoidal waveform is like this is this one. So this quantity at some instant of time t represents what? This value. Correct?
Yes, sir.
That's what you have to understand. That's what you have to understand. Now here you see this value will change in accordance with the modulating signal. So modulating signal has got this form, AM sin omega m. And remember only, remember, this omega m is very small compared to omega c. Keep this in mind. Correct? This is not equal, it should be lesser than this. So that's the meaning. So if you see the equation there, Cm of t is what? That is, this signal has modulated, or this signal is superimposed on this signal. And the process here is that, you see this signal undergoes a change. What is the change it is undergoing? It becomes AC plus AM sin omega m t Okay, see here. Into sine omega c. So that means now this part is retained. This part is changing like this. So you can see now that this new waveform has a frequency omega sine omega ct, but the amplitude now, you see, if you say now this part is the amplitude now depends upon this. You got it?
Yes.
So that means now AC is a number. Now what is this? AM sine omega mt. This is also a number. Hello. So AC is, that means now AC is a number. Now the maximum value of this part will be plus AM and the minimum value of this will be minus AM. Correct?
Yes.
That means now the resultant waveform, this is a resultant waveform. This resultant waveform will have what amplitude? The resultant waveform will have amplitude AC plus AM and AC minus AM. Got it? Hello?
Yes, sir.
Now the most important thing is, see, slowly and steadily learn. See, now when you do the multiplication, see, when I open the bracket, I am going to get AC sine omega ct plus AM sine omega mt into sine omega ct. Okay. Now, as a consequence of this, in reality, you will see the initial carrier is like this, and the modulating signal is like this. So what happens is your carrier now, see, this is m of t and this is c of t. The modulated signal will it will start looking something like, I think the annual output is something like this. You will see this on the oscilloscope. This is a reality. Now, this expression, if you expand and properly manipulate it, you will be able to see something very interesting. Now, this waveform is not a pure sinusoid, but yes, it is a combination of many sinusoidal functions. That is what you have to understand. Now, what are those sinusoidal functions which combine to give you this? We will see. Which are the components which will do it? We will just find out. Now, follow this equation. Equation 15.3. Hello?
Yes.
Now, here you see in your textbook,
Yes, sir.
Cm of t is equal to into bracket AC plus AM sine omega mt into sine omega ct. That you are seeing clearly is equal to, you are seeing there AC, some space and something and all. Correct?
Yes, sir.
So there is, something is missing there. That is, after writing this step, what they have written is AC into bracket 1 plus AM by AC. Hello?
Into sine omega.
Sine omega mt into sine omega ct. Okay? So this bracket is missing in your textbook. I just put that bracket there. Okay? Right. That's it. So that is it. Now further manipulation is doing here. Note that the modulated signal now contains message signal. This can also be seen in 15.8c from 15.3. Now open this bracket. You will get equation 15.4. Cm of t is equal to AC sin omega t plus AM by AC. This ratio is written in the form of mu. It is called modulation index. It is called modulation index. You will understand the significance of that shortly. So mu AC sin omega mt into sin omega ct. Got it? 15.4. Hello?
Yes, sir. Yes, sir.
So now it is multiplication of two sinusoidal signals. That is sin A into sin B. And you are all mahirs. So the moment you are given sin A and sin B, and now you have to find out the components. So you will convert it into sin of what? Sin A into sin B. You will convert it as sin A plus B into sin plus sin A minus B. Correct? So you will get here, and you are good in mathematics. Looking at equation 15.4, you can quickly see that the Cm of t has three components, three sinusoidal components. One is AC sin omega ct. Another one will be mu AC divided by 2 into sine of omega m plus omega c t plus mu AC divided by 2 into sine of omega m minus omega c t. That means you have three components: omega c plus omega m, omega c minus omega m. Correct? Yes, you didn't get it, but go ahead. Look at equation 15.5. Look at equation 15.5. You get three components. Clear?
Yes, sir.
Without any difficulty, these components are represented in equation in the figure 15.9. So it is the plot of amplitude versus frequency. You will see three distinct lines. Okay, three distinct lines, right? I think you are familiar with this. Okay, line spectrum. So you have got omega c, and you will get two daughters. Okay, so this is omega c minus omega m. This is omega c plus omega. And this amplitude, see, this amplitude is what? AC. And what is this amplitude? This will be what? Mu AC by A. See, what is this amplitude? Mu is AM by AC. Hello?
Yes, sir.
Mu AM by AC, isn't it? So you will get mu by 2. Is the amplitude of this. And these two are called side bands. Side bands. And this, of course, is the carrier. Correct? Sorry, mu, this is mu AC. I have written it correctly. Mu AC by 2. These two are called side bands. Hello, are you with me? Now understand. That means now the modulated signal is a composite signal. What did I say? You see, this is a composite. Just like our light is composite, it consists of 7 colors. Okay? So you see white light, but if you pass it through the prism, automatically they will split into 7 colors. Okay? Same way, this entire modulated signal is one signal. But if you pass it through proper filters, then immediately it will get split into 3 components. See, what I mean is, now that you have got a modulated signal coming here. This modulated signal has got 3 components: omega c plus omega m, and omega c minus omega m. Correct? So this modulated signal has got these 3 components. Correct?
Yes.
So it will look like one signal. Now
Yes.
this signal you pass it through three band pass filter. See, band pass filter means it will pass only set of frequencies. Okay? Now you understand this. If I have a filter, see, this is a filter, okay, whose characteristic frequency, filter characteristics, A versus F, A versus F is like this. This is omega c minus omega u. You understood this filter, what I have written here? If you have not understood, you should ask. If you have misunderstood also, you should ask. What I mean is, see, what does this characteristic mean? That means this filter will allow all these frequencies from 0 to omega m, but it will not allow any frequencies above omega c minus omega m. Got it? Filter will allow all frequencies below this frequency, but it will not allow any frequency above this frequency. Got it?
And that particular frequency?
And that particular frequency means what?
Omega c minus omega.
That is included. Good boy. When I draw it like this, that means this is also included.
Yes, sir.
Thank you for asking. That's also included. Okay, understood?
Yes, sir.
That means what will be the output of this here? If I am giving this waveform, what will be the output?
Omega.
The only waveform that you will get is omega c minus omega c. Clear? Now I will have one more filter here. Okay, whose characteristic is like this. This is omega c. That means all the frequencies below omega c and all the frequencies above omega c are cut off. Only omega c frequency is allowed. Got it?
Yes, sir.
Yes, sir.
Yes, yes, sir.
Why don't you all be enthusiastic, man? I will get the understanding that you have understood. Otherwise, I will keep on explaining this. See, my theory explanation has got extended because of non-cooperation movement from all of you. You have to steadily keep it. See, in the classroom, I can see you. I will not ask you, oh, it did yes, 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 like that. Because looking at your face, I can understand. Here, what can I see? Huh? Only your voice. Okay. So, what will I get here? Output? Only omega c. Got it? What you can carry there? Now. Here, what type of filter will I write?
Omega c plus omega.
So I will have the filter like this. This point will be what? Omega c plus omega m. And what will I get at the output here? I will get here omega c. The signal having omega c plus omega m. Got it? Now this is called LPF, low pass filter, right? And of course, if I should show it like this, then this is called band pass filter. Why band pass? It is allowing a band of frequencies, right? And this is what I will call it as high pass filter. Means it is allowing only high frequency components. Got it?
Yes, sir.
So if I have three filters like this, I can separate out these three components. I don't have to do anything. Sunlight, if you pass through prism, prism will act like a filter. I mean, it will act as a device which will split the composite light into components. So here, these filters are acting as components, are acting to split the composite waveform into three different waveforms. Got it?
Oh, no.
Ask.
Sir, will these waveform be continuous from this?
Continuously, yes. Why are you having that doubt?
Sir, when you modulated, on some part of the wave have a particular frequency and other part in the other frequency.
No, that is what you are not understanding. See, now understand this like this. Understand this like this. See now. Understand this very carefully. You listen to me very carefully. If I am drawing a pure sinusoid, it has got only one frequency. Right? Now, supposing I draw something like this. Now, this contains just not F0, but it will contain, see this waveform. This waveform will contain F0 plus 2F0 plus 3F0 components like this.
Yes, sir.
That's it.
Okay.
That's it. Now, sir, how those components that you will learn in higher classes. That's what I can tell you. Or after your This one you come, I will explain to you how there are other components. Okay, that's it. See, if it is other, see, now the thumb rule is this. If it is sinusoidal, only one frequency component. If it is other than sinusoidal, it contains many frequency components. That's all. Okay?
Yes, sir.
That's it. Okay, then. So, therefore, you understand that this is amplitude modulated wave. It contains, you can pass it through filters and you are able to get all these different components that can come out. Now, this is called upper sideband, this is called lower sideband. This is how the things look. Now, these two sidebands, they contain information. Correct? This does not contain any information. Is it clear?
Yes.
That is also clear to you. Fine? Right. Okay. So, amplitude modulated wave is created and it is transmitted. At the receiver, we are going to receive this. We are going to receive the signal. Okay. So, at the receiver, when we receive the signal, we can have three filters like this and filter out these components. Clear?
Yes, sir.
Now there you see at the receiver, I told you we have got a tuner. Okay, what will the tuner do? It will adjust the bandpass filter and all these filters to achieve these points. And that is how the RF stage, the radio frequency stage, the initial stage is able to pick up the station. Choose, select. You remember that? That is how it happens. So this is the mechanism. Okay.
Is this what is demodulation, sir?
No, not it. I have not taught you demodulation. Have I used the word demodulation?
No, I asked, sir.
Have I? No. I am only telling you the characteristic of the modulated signal. See, what I want you people to now understand here is, well, you are generating a composite signal by a process, and that composite signal consists of only three frequency components. These are this. And I want you to understand that this is composite. That means it has got three alag frequency components. And these are sidebands. They contain information. That's it. Okay?
One more. Sir, these separated waves, sir, they have their respective amplitudes or the...
respective amplitudes. So, if there is no loss here, the amplitude of the signal will be mu AC by 2. This will be AC, and this will again be mu AC by 2.
Okay.
Done. Now, as long as the broadcast frequencies are sufficiently spaced out, these sidebands do not overlap. Different stations can operate without interfering with each other. Did you understand that statement?
Yes.
What you understood, you tell.
Sir, for different broadcast like channels, sir, if they allocate different frequencies, sir, they won't interfere and they won't affect the information of each.
Can you elaborate and explain?
Sir, like if they have different carrier frequencies, sir, so the information sent by one will be received by its receiver and will not be affected by other frequencies.
Okay, fine.
Yes.
I understand that you have fairly understood. Let me just make sure that you have understood.
Yes.
So now you see a particular station, say Gulbarga station. It will have this. So if I start with frequency, this. So this is Dharwad station. So this will be omega d minus omega m of Dharwad station, omega d plus omega m of Dharwad station. Got it? Now listen here. Now this is the carrier frequency for Dharwad station. Now this is the carrier frequency of Gulbarga station. Now understand one thing. This will have sidebands. Understand? So this is Gulbarga station. This is Dharwad station. Got it?
Yes.
Now you see. Now supposing This is Dharwad station, okay. And supposing this is Gulbarga station. This is Dharwad station and this is Gulbarga station. Okay, there is difference between the two carrier frequencies, correct? Hello?
Yes, sir.
Now,
Yes, sir.
tell me, will this work satisfactorily? Will this work satisfactorily? It may or it may not. See here, this will have sideband here. This station will have sideband. Now, this station will also have sidebands. So now the bandwidth of this is this, or the range of frequencies are this for Gulbarga. The range of frequencies for this is this. Now you can see both of them are overlapping. You got it? So it is not only the question of the two carrier frequencies, but also the bandwidth about the carrier frequencies. They should not overlap. Got it? They should be spacing between the upper sideband and the lower sideband of two, like how it is here. Here you see, here there is a difference between these two. And if this is sufficiently large, then there is no overlapping. Got it?
Yes, yes.
That is what they have told. Sufficiently spaced that the sidebands do not overlap. Different stations can operate without interfering with each other. Right. I hope that is also clear.
Yes.
Now the last part, the most interesting part. The production of the, see, now you have understood what is amplitude modulated. So there you see there is a mathematical formulation for that. So you are multiplying, two signals and you are able to get the output. Okay. Now you are going to study still more. Okay. Now what are you going to study? How are you going to cause the multiplication of this? Multiplication is modulating signal is multiplied with the carrier signal. That is what was the expression 15.1, 15.2 equations. Correct? How is this multiplication possible? That is what you are going to now understand briefly. Okay? See, so wonderful this textbook is. It's making things really interesting and we would like to go on learning. Anyways, enjoy this. Now, production of amplitude modulated wave, 15.9. Hello, are you all with me?
Yes, sir.
Now,
Yes.
here you see M of t and C of t, and there is something plus sign there. So, plus sign means they are adding M of t signal and there is C of t signal. They are simply added to one another. So this is called an adder, basically. So the first stage will be an adder. Now don't ask me what is there inside the adder and all. If time permits, I will explain the circuitry there. But right now, please restrict yourself. Okay? These two get added. Right? These two get added. Right. And then the resulting thing is what? You are able to generate another signal which is x of t. What is x of t? X of t is nothing but M of t plus C of t. So you are getting x of t. Clear? Hello?
Yes, sir. Yes, sir.
Then you will pass it through a circuit which is going to do what? Which is going to square. So there is something called as square law device or square law circuit. Square law. So what it does, it squares this signal. Just like how you do mathematics, the circuitry itself can do the squaring operation. Okay? Now that's what you are going to learn in higher classes, lower classes. Okay? If you want briefly to tell you, you see here, you know a diode characteristic? Hello?
Yes.
How is the diode characteristic? The diode characteristic is like this. So now, see, now if you want, see, now you take mathematics book, right? You know functions. You have studied the chapter called functions. F of you are studying f of x. You remember function, right?
Yes.
Now f of x function you should get this. You should get a function f of x like this. This is f of x versus x. You should get like this. So now, if you do proper mathematics, you will find here there are terms here a1 x1 square plus a2 x2 a1 x1 a1 x2 square, okay, sorry, a1 x plus a2 x square plus a3 x cube plus so on and so forth. What I'm trying to tell you, if you want to realize such a function, f of x is this, then you will find that it contains many terms. When added, you are going to get this. Is it clear? That means this function contains squares and cubes and fourth powers and fifth powers of x. This also already contains. Okay. Now all that you have got to do is pass this through a filter, which will only abstract square. Correct? But here you see the thing is that if you want only this, then you have to have high selectivity filter. But usually what they do, we put the band pass like this. That means we are able to select these two components. That is why you see here, the square law device x of t is going to give you an output. What is the output you are getting from that? You are going to get y of t. You are going to get y of t. And what is y of t? You see that it is b x of t plus capital C x square of t. That means you have simply added these two signals. You got x of t, the combination of these two. This you pass through a square law device. Basically, this device is something like this, and with the filter, this plus a filter, and you are going to filter the first component and the square component. So y of t contains these two. Correct? Enough?
Sir, how did you get cx square?
See, this square law device contains this type of a function. Correct? This type of a function means it will contain x and x square. Correct?
Okay, sir.
So that is why I have written, see here, instead of A1 I have written B, instead of A2 I have written C, capital C.
Okay, sir.
That's all. That's all.
So that x is same as that x of t, no?
See, x is same as x of t. You get that as an output. Okay? Clear? Hello?
Yes, sir.
Right. Then you see, they have written here band pass filter, band pass filter, band pass filter, band pass filter, centered at omega c. Centered at omega c. This is the band pass filter. Correct? So what will you get at the output here?
The frequency is around omega c.
Frequency is around omega c, and that is, and these two things, what is this? This is what? Omega c minus omega m, and what is this? This is omega c plus omega m. So at the output you are going to get all these three frequency components. Which are the three frequencies? All the frequencies in between this you are going to get at the output, and you have generated the amplitude modulated frequency. Okay?
Yes, sir.
ಉಳಿದವರು ಎಸ್ ಇಲ್ಲ ನೋನು ಇಲ್ಲ.
Yes, sir. Yes, sir.
ಇದು ಸೂಪರ್ಫಿಷಿಯಲಿ ತಿಳ್ಕೊಂಡ್ರೆ ಉಪಯೋಗ ಇಲ್ಲ. If you superficially learn, no, you try to understand as much profoundly as possible. because they are not going to ask any superficial questions in the competitive examinations like NEET and mains. They are going to ask you something profound, something deeper. So you try to understand as deep as possible. Don't simply try to superficially read something and say, I have understood that. Right? No. And I am giving you enough scope to ask question and understand. Right.
Sir,
Yeah.
sir, centered around omega c means, sir,
Yeah.
would that allow only like omega c?
सब जोर क्या की तो होती नहीं.
Sir, centered around omega c means it will only allow omega c.
See, band. See, listen. Now listen. Very good. This is called band pass. Got it? So it has got lower and higher cutoff. And this is the center. Centered around this means this is the center. Around this, you are having this band pass. So it will allow. You can make it like this. See, it is up to you. You can make a band pass filter like this also. You can make it like this also. It's up to you. You can design it like that, the way you want. So the lower and the upper frequencies is under your control. It is under you. It is a design parameter. You design it and build it. It's up to you. Got it?
Yes, sir. Yes, sir.
That is precisely what is done. Then you please go ahead. So here B and C are the constants. I am reading equation 15.6. I am reading equation 15.6. Right? 15.6, 15.7, 15.8. And so on and so forth. Clear? You understood 15.6,
Yes.
15.7, 15.8, they are simply simple mathematical functions. You have done much higher mathematics than this. Okay, now come to this last part. Figure 1511, block diagram of transmitter in nutshell. Okay, so I have already told you power amplifier, if you remember. So M of t is fed to amplitude modulator, just now that we said. To the amplitude modulator you are feeding the carrier, and then last stage you have got power amplifier. So I told you what is power amplifier. It is going to boost the power, mainly the function of that is that, and also do the impedance matching, right? And then things are set into the antenna and the electromagnetic waves is propagated. Clear, friends?
Yes, sir.
Great. Now the last part is very important, and many questions, many year question paper will contain questions on this last part. Very interesting. Okay, so understand again here very thing, because there is a question asked on intermediate IF stage. There is a question asked on IF stage also. I will elaborate that IF stage for you, right? That is, if you remember the block diagram that was written, so you at the receiver, if you remember the receiver, receiver, okay, so you have the antenna, and then you will have here what is called as tuned RF amplifier. I suppose all of you remember this, tuned RF amplifier. Then you have got what is called as the IF stage, intermediate frequency stage. Okay, so this can be IF1, and this can also be one more stage, can also be IF2, like this can be there, or sometimes only IF1 is sufficient. It depends upon the design and other things. So it is called intermediate frequency amplifier. Now here you see, here the say Gulbarga station or something, no? So the station, this will receive say Dharwad station, so it is carrier frequency is 540 kilohertz, 540 kilohertz plus its sidebands plus delta band. Now I want, so this signal that it is receives here has got powers which is in the range of microwatts and milliwatts only. That is the power. Now, the main function of this RF amplifier is to receive, select the required station and because see, the circuit design is more focused on selecting the required frequency, required station. Main focus is that, and very little amplification is possible. Okay. So, but this signal that is going to come out will still have 540 kilohertz. Now, as I told you, in an amplifier, there is something called as gain into bandwidth. So, for an amplifier, this is constant. I hope you understood. So, if you want higher gain, then you have to go settle down for lower bandwidth. So, if you want higher bandwidth, you have to sacrifice the gain. I suppose you understood this. So, therefore now, there is one aspect. Gain, bandwidth is one issue. Second thing is the highest frequency that it has to handle. Highest frequency that it has to handle. Now, here you see, what is the highest frequency that it has to handle here? Omega C, see here. Here it's a modulated signal. Modulated signal will contain omega M1, omega M2, omega M3, omega M4, so on up to say some omega Mn. Means, see, when I am speaking, I am generating many sinusoidal signals. Got it? If I am singing a song, I am generating many frequencies. Got it?
Yes, sir.
So that means I will have one lowest frequency and one highest frequency. So that means now the signal that is going to come here, it will have highest frequency will be omega C plus omega M highest. Got it? That is the highest frequency that this has to handle. Hello, are you with me?
Yes.
So here at this stage, what happens at this stage is basically, now this omega C plus omega M is there, no? Okay. Now here a process takes place. Here a process takes place, and the signal that comes out here will be omega C dash plus omega M highest. Now let me tell you, this omega C dash will be lesser than omega C. That's the process. That means now the signal that is going to come out of this stage will be like this, where omega C dash is less than omega C. Got it?
So, why it is?
Why? Because see, that's what I said. Now the amplifier has this thing. So all see, if you want the amplifier to handle very high frequency, then there are some issues. There are some issues like stability issue of the amplifier. Amplifier should be stable. Okay. Now what happens is the amplifier becomes unstable. That means it cannot amplify faithfully. It can cause the distortion. There are some issues like that. So, but the lower the frequency the amplifier can handle, the better it can handle. It is difficult for the amplifier to handle higher frequencies. Got it? It is difficult to handle higher frequency. It is easy to handle lower frequencies. So the amplifier, see, supposing I am the amplifier, you send me low frequency signals, I will amplify very nicely. But if you send me high frequency, I can't. It is difficult for me to handle. Understood? That's how an amplifier will speak. So therefore, but one more thing is there. See, कुछ पाने के लिए कुछ खोना पड़ता है. So here you see, here the process here is I am going to reduce the frequency. See, it's all about frequency translation. I am going to now here please understand. What is amplitude modulation? It is frequency translation. I suppose you understand. That is, the modulating signal has got low frequency. Now this is translated into high frequency. Got it?
Yes, sir. Correct.
Huh? And now what I am going to do here in the intermediate stage is I am going to translate this signal into another lower signal at this point. Got it? So that at the next stage handling becomes easy.
Okay, yes.
At the next stage handling becomes easy. That's it. See, at every stage, you know, कुछ होता है. That is why you will get so many amplifiers. इसका काम ये है, इसका काम है, इसका काम है, इसका काम ये है. There are specialist amplifiers. एक ही एम्पलीफायर में सब कुछ नहीं हो सकता. ठीक है? हेलो, जिंदगी ऐसा है. ठीक है? Say tomorrow you say, so I want a teacher like this. You define. See, small children, you know, how do you want a teacher? My teacher must be like this. He must be handsome. He must be jolly. He must be very, very highly educated. He must be a very good teacher. He must have a lot of knowledge. So many qualities you will get. Can you find a teacher with all these qualities? No. Some may have this quality, some may have this quality, some may have this quality. But life is like that. You are and I like this. So this whole world is a real world. Okay. So therefore, you will have to build series of amplifiers. Each has got a specialist function. Together they form a system. That is why it is communication system. Correct?
Yes, sir.
Okay, so let me read out. Detection of amplitude modulated wave. The transmitted message gets attenuated in propagating through the channel. The receiving antenna is therefore followed by an amplifier and a detector. In addition, to facilitate further processing, the carrier frequency is usually changed to low frequency by what is called as intermediate frequency stage preceding the detection. Understood? I have explained this intermediate frequency.
Yes, sir.
Then after this stage you have got what is called as detector. Detector means this is basically going to what? It is going to detect the message signal in the composite signal. हेलो. हाँ, देखो आपको 3 सिग्नल्स मिल रहे हैं, ओमेगा सी प्लस ओमेगा एम एंड ओमेगा सी माइनस ओमेगा ए. देखो क्या करोगे, इसमें तो ये तीनों आता है. ठीक है? इसमें भी ये तीनों आ सकता है. ठीक है? या either all the 3 will come, or this and this will come, or this and this will come. Correct? Here you can have omega c and omega c plus omega m, or you can have omega c and omega c minus omega m. Got it? See, we are not interested in both the side bands. We are interested in the message. The message is in this also, in this also. So I have an option to either select this or this along with this. Got it?
Oh, yes.
Malum hua? Logic? So I will select one of them. Say I will select this. Got it? So I will get at the output what? I am going to get here omega c plus omega m is going to come at this. Got it?
Sir, how will that happen, sir? Like,
how will that happen means? How will what happen?
Like the selection of omega c plus omega m or omega c minus.
Band pass filter लगा लो. Band pass low pass filter लगा लो. Low pass filter high pass filter हो जाता है. High pass filter लगाए तो you will get omega c plus omega m. Low pass filter लगाए तो omega c minus omega m.
So then it is better to capture one of them and excluding omega c, no, sir.
Wait, see, omega c is necessary. Omega c will be necessary. Why it will be necessary? See here. See, I will get omega c plus omega m or omega c minus omega m. Either of them contain information. Correct?
Yes, yes, sir.
ये बनाने के लिए हमने क्या किया, इन दोनों को इसमें डाला था. मालूम है? हेलो,
Yes, yes, sir.
अभी हमको क्या करना है, उसको जुदा करना है. तो अगर हमने ये we have chosen this, then what I will do? I will now use a subtractor. So this will contain omega c plus omega m. Then I will send here omega c which I have abstracted. So इधर क्या होता है, माइनस सब्ट्रैक्टर. सो इसमें से सिर्फ मुझे निकलेगा omega. तो मुझे ये चाहिए. तो RF सिग्नल में I want the carrier. I want the carrier because I will use that carrier to do the next operation.
Okay, yes, sir.
Or I will internally generate the carrier. What carrier तो चाहिए, मालूम हुआ अभी?
Yes, yes, sir.
हाँ, okay, हाँ, yes. So I will be able to subtract and get the omega m out. Is that clear?
Yes, sir.
Sorry, not here. Here, I am going to get omega m.
Omega, yes.
Got it? Huh. Okay. Now this subtractor, what is it? Just subtractor. You understand? Very carefully. Okay. So for that also very nice diagram is given here. Okay. Now you can see this diagram 15.1. Students, actually, you know, I love to teach this subject, drawing all these diagrams, etc. in my own hand. But just see, if I do that systematically, I will be needing at least 5 to 6 classes to do all that very nicely, all the equations, etc. But now that I have to complete the syllabus by the end of this month, still one more chapter is remaining. So anyway, the book is there, you have got these diagrams, so I am using it and doing it. Okay, otherwise I love to draw all this stuff. But anyways, my job is to ensure that you have understood. And what best resources are available with me, I am using it and doing it. Okay, now here, I suppose you are seeing 15.12.
Yes, yes.
Okay, now detection is a process of recovering the modulating signal from the modulated carrier wave. We just saw that the modulated carrier wave contains frequencies omega c plus or minus omega m. In order to obtain the original measured signal m of t, of the angular frequency omega m, a simple method is shown here. Okay, you see the simple method here. So you can see AM wave here, which is like this envelope. Hello?
Yes, sir.
And then you pass it through a rectifier. Okay, what will the rectifier do? It will either chop off the negative part or the positive part. One of them it will allow.
Yes, sir.
See, you know, no, it's rectifier.
Yes, sir.
So if you are given the sinusoidal signal here, like this, so at the output, what did you get? You only got this. And supposing you have used full wave rectifier. You have used full wave rectifier. Okay, then at the output, you are going to get what? You are going to get this. Clear?
Yes, sir.
So here you have got a waveform like this. What is it? Okay, so if you pass this through this, only the upper part is passed through. The lower part is cut off. Got it? Hello, got it? So that is why if you pass a AM wave through a simple rectifier, you are going to get the output like this. Got it?
Yes, sir.
Yes, sir.
So if you have understood this stage, I can explain the next stage to all of you. So envelope detector. So here you have got a forward full wave rectifier. And then it is very simple. All that you have got to do here is you must now have a RC circuit. Now see here, the signal that is going to come here is like this. Can you see this? Hello?
Yes, sir.
So the signal that you are going to get here will be like this. Understood? It will be like this. That will be the signal that is going to come here. So if you carefully observe this here, this signal has got two components. Which are the two components? One is omega c and the other one is omega m. Got it? And omega c, as I told you, is very much larger than omega m. Got it?
Yes, sir.
Now, see, this is R and C. This is R and C. So if you take this as a system, it is you have got R and C. Okay, R and C. So if you see this as a system, okay, so this is the input and this is the output. Got it?
Yes, sir.
So now, what is the input impedance? Input impedance of this. What is input impedance of this? If you see from here, what is the input impedance? R minus J by X. Correct? Sorry. R minus Jx. What is this? R minus J by omega c. Correct?
Correct.
Hello, all of you are with me or no?
Yes, sir.
Right. So now,
Yes, sir.
if you plot the impedance versus frequency, how will you get the plot?
Impedance will decrease with increase in frequency.
How will you get the plot? So at omega is equal to 0, the modulus. So I will say modulus of Zin. What is modulus of Zin? Modulus of Zin will be R square plus 1 upon omega square C square. Correct? If I am going to say what? Modulus. C. What is sorry?
Root of.
So modulus of Zin will be what? Root of this. So you can very well see, if omega is very less, then this factor will be very large. So you will have, the point will be almost infinity. And if omega starts increasing, then this factor will start decreasing. R will remain constant. So you will have the impedance like this. Correct? Zin versus omega will be like this. Agreed?
Yes, sir, correct.
Yes, sir.
So what do you mean? That means now this circuit, especially this capacitor. See, the signal will come up to this point. At this point, the capacitor impedance for low frequencies is very high. The capacitor impedance for low frequency is very high. That means lower frequencies will find more impedance, so they don't travel like this. So therefore, they will travel here, low frequencies.
Yes.
Now, higher frequencies, you see here higher frequencies. For higher frequencies, the capacitor will act like a short circuit. So, higher frequency components will go here. That means this signal will have two components, omega c and omega m. Omega c will go into the capacitor. Okay? Hello?
Sir,
हाँ.
so omega c also can go direct, like straight plus.
हाँ, देखो, just see this here. Now, supposing, see, now there is a road here. Hello, there is a road. Hello,
Yes,
are you with me? Now there is a hole in the road. So you put water like this. So yes, when you put water like this, depending upon the force, some water will go that side. But most of the water will go inside the hole.
Correct.
It's not, see, the thing is that it is not that high frequency will not come here. Some will come, but maximum will go here. 95% of the high frequencies will go here, only 10% or even 5% of them will come.
Okay.
For all practical purpose, that is neglected. Got it?
Yes, sir.
So therefore, you are going to get here what? At this point, this is the signal that you are feeding, and at this point, you are going to get the message. So a combination of a rectifier and an RC circuit, which is an envelope detector, you will be able to get the message. This is in principle, but actual design and all will be much more complicated. Okay? This is just to give you an explanation. I'm giving you like this. This is the principle behind this. Okay, friends? Did you understand? So envelope detector, you will get the output like this. Okay? Clear? Understood?
Yes,
Hello. Now remaining part, internet, facsimile, mobile telephony. Okay, if they ask any question on that, you will write PhD on that. I know. So I will not touch upon those things. Okay. So the theoretical part of this I have ended today. Got it? Hello.
Yes, sir.
Now what I would want you is you go through the questions at the end and try to solve them. Okay, and whatever you have got, fine. Whatever you have not got, it's also fine. I will discuss that later on, because I want to give you time to go through this chapter, solve some questions from your modules and things like that. And wherever you have doubt, you mark it and keep it. After, see, from tomorrow I will start with the next chapter, which is it? The experiments. Experiments in physics, right? Units, measures, okay, errors, experimentation. That section I will start from tomorrow. Next 3-4 days I will do that, and after that again I will come back to this communication part. So by that time you would have gone through some numericals, etc., and you would have got some problems. You post it to me. I will make sure that I will discuss it in the class. Clear, students?
Sir.
So all the best. See you tomorrow for what? Units, measurements, and dimensions, and some important experiments. Okay, I will take that for next 2-3 days, complete it, and then once again I will come back to this. So by the end of this month, 100% your syllabus I would have completed, first year and second year, with the revision of all the mechanics topics. Right? So next month I will devote it for revision of the important second year topics. Okay, phase 2 revision, and once we complete that entire revision, we will go in for full length papers. Okay?